Good morning, students. So in our last class we discussed about some miscellaneous examples. So now today we have to start the miscellaneous exercise from the chapter complex number and quadratic equations. So now if you see the first question here, the first question is given in this way. Evaluate, the question is here already given, and now what you have to do, we have to find out the value of I from here, isn't it? So very simple question here, just we have to break this result, and already we know there are four results are there: I to the power 4k, I to the power 4k plus 1, I to the power 4k plus 2, and I to the power 4k plus 3. So these four results already we discussed in earlier class. So with the help of these results, so easily we can evaluate this result, and from here we get the answer. Is it clear? So now let's see how can we do this question. If you see the question here, the question is given in this way: I to the power 18. So I to the power 18 plus this one is 1 by I to the power holding to power 25, and this one holding to power 3. Isn't it? The question is this one: I to the power 18, I to the power 18 plus 1 by I to the power 25 holding to power 3. So now first of all, what you have to do here, first of all, if you see here I to the power 18 is there, 1 by I to the power holding to power 25 means what? Easily we can write I to the power 25 here, isn't it? So now here, if we break this result now in the form of 4k plus 1, 4k plus 2, or 4k plus 3, that means the multiple of 4s. So now here in this case, what you have to do, I to the power 18, that means we can write here this one. If we convert this one into multiple of 4, then we have to write here I to the power 4 into 4. 4 4s are 16, then 16 plus 2, 18, I to the power 18. Plus up. Now if you see the second part, so in the second part this one is 1 to the power 25 means 1 here, I to the power 25. So I to the power 25 means if we convert this one into multiple of 4, so 4 6 are 24 here, isn't it? So it is 25. So 4 6 are 24 plus of 1. Is it clear? So in this way we can break this result. So here first one we write I to the power 4 into 4 plus 2, 18. Here I to the power 4 into 6 plus 1, that means 25. So after that, now here some results are we know. If we write these results here inside, if you see I to the power 4k form, if we get I to the power 4k form, that means the value is always 1. In our last class or in earlier classes we discussed this result. Then second one is of the form I to the power 4k plus 1. So if we write I to the power 4k plus 1, then simply we write this result is what? I. So next one is here we get I to the power 4k plus 2. If we write I to the power 4k plus 2, then the result is what here? Minus 1, isn't it? And the last one is here I to the power, this one we have to write 4k plus 3, and I to the power 4k plus 3 means what we have to write here? We can write here minus of I. So these four results are in our earlier class we discussed, isn't it? So with the help of these results we have to evaluate this one. Now if you see here, the first one is, it is of the form I to the power 4k plus 2. It is of the form 4k plus 2. If we write 4k plus 2 here, you see 4k plus 2, then the result is what we get here? Minus 1. So that means in place of this one we have to write minus of 1. So that means this one we write minus of 1. And similarly, if you see this one, next one is 4k plus 1. If you see here 4k plus 1, the general form of 4k plus 1 is what? I. So it is of the form 4k plus 1, isn't it? So 4k plus 1 means I. So in place of this one, what we write here? I. So that's how we have to write here plus of 1 by I. So 1 by I holding to power, the power is given here 3. Is it clear? Very simple. With the help of these four results, easily we can convert this one into minus 1 and I. Is it clear? Okay, now after that what you have to do? We have to eliminate this I from here first of all. So how can we eliminate this I? So we have to multiply it by their conjugate, or simply what you have to do to balance this result, to eliminate this I from here, if you multiply numerator and denominator by I here, then we get I square. I square means what? Minus 1. So easily we can convert this result. So in this case what you have to do, this one we have to write here, minus of 1 is here, so plus of, I think all of you understood this one. If we write like in this way, I divided by I square holding to power 3. Is it clear? Understood or not? Multiplying numerator and denominator by I. So what is the value of I square here? I square means minus 1. So ultimately what we get, the result we get here, this one is minus of 1 minus of I whole thing to power 3. Is it clear? So now we have to break this result in the form of a minus b whole square or a plus b whole cube here. If we break this result, then easily we can find out the answer. Is it clear? Okay, next one you see here. After this, if you see here, minus 1 minus I whole cube, isn't it? So now first of all what you have to do, if we take minus 1 common from here, so if we take minus common, so that means minus of 1, if you common, then the power is whole cube here, so we have to write whole cube also. Here minus 1 whole cube. So here it is, we write here whole cube. Then if we take minus common from here, then what will remain here? 1. And here what will remain? Plus I. So that means we have to write this one is 1 plus of I. So 1 plus of I, this one we have to write whole cube. Is it clear? Minus 1 we have to take common from here. So now after that, if you break this one, so you see here minus 1 whole cube means simply we write minus here. So it is of the form a plus b whole cube. Now if we write a plus b whole cube, then what you have to write? A cube plus b cube plus 3ab. A means 1, b means I, into a plus b, that means 1 plus of I. We have to write this in here. Is it clear? A cube plus b cube plus thrice ab into a plus b. So now if you calculate this result, minus of this one, if you see here, this one simply we get 1. Then what is the value of I square? Oh sorry, no, this one is not I square, this one we have to write I cube. So now because it is of the form a cube plus b cube, so that's why here I 1 cube 1, I cube means what? I cube means simply we write here minus of I, so we have to write this one is minus of I, plus this 3 into I, 3I into 1, that means 3I, then 3I into I, that means what you have to write? 3I square. Is it clear? So now if you calculate this one, minus of this one is what we get here. This one 3I square, that means simply we write here 1 minus I plus 3I, that means plus of twice I, and simply this one is I square means minus, so that's a minus of 3. So ultimately from here we get this one is 1 or what we need? Minus 3 plus 1, that means minus of 2 plus of 2I. Is it clear? This one we get here minus 2 plus 2I. So now here minus is there. If we multiplying by this minus, then finally what we get here? The answer we get here 2 minus twice I. So this one is our required answer. Is it clear? 2 minus twice I. I think all of you understood this one. This one is only the calculation part here. So if you understood, then you can skip few lines from here if you understood. Is it clear? Okay, now the next question is question number 2 here, and if you see the question here, for any two complex numbers z1 and z2, two complex numbers are here given, and what we need to prove here, real part of z1 z2 equals to real part of z1 into real part of z2 minus imaginary part of z1 into imaginary part of z2 we have to prove here. Is it clear? Very simple question here. First of all, what you have to do, the complex number whatever we know, a plus ib form or a minus ib form, is not it? So here two complex numbers are given, and these two complex numbers are what? z1 and z2. So first of all, what you have to do, we have to assume these two complex numbers. So that's why first of all, if we write here, let z1 equals to the first complex number, if we write z1 equals to, if we write x1 plus I y1, and another complex number z2, and this one we have to write here x2 plus I y2. These two complex numbers we consider, we assume in place of z1 and z2. Is it clear? So now first of all, what we need? Real part of z1 z2. So for real part of z1 z2, first of all, what you have to do, we have to multiply these two. z1 z2 we need, so that's why we have to multiply these two. Now if we multiply these two, let's see what we get. Now z1 and z2, if we multiply these two, then this one we have to write here x1 plus I y1 into second one we have to write here x2 plus I y2. So we have to multiply these two. So here x1 into x2, so that's why we have to write this one is x1 x2 plus second one we have to write here x1 into y2, that means this one we write here I x1 y2. So this means this x1 we have to multiply with x2 as well as this x1 we have to multiply with y2. Is it clear? Next what you have to do, we have to multiply this I y1 with x2. So that's why we have to write here plus, if we write x2 first, so that means I x2 y1, I x2 y1, we have to multiply this whole result with this x2. Is it clear? Then next I into I, that means we have to write this one is plus of I square, I into I square, y1 into y2. So that means this one we have to write here y1 into y2. Just we have to multiply these two results. Is it clear? Okay, now after multiplying this one, now if you see here the real part is x1 x2, and here I square means what? Minus 1. So that means this one is also the real part here. So that's why we have to write this one is x1 x2 minus this one we have to write here y1 y2. Is it clear? These two we have to write first. Is it clear? Next one is here plus I, that means I here, if you take common here, then this means this one we have to write x1 y2 plus x2 y1. Is it clear? So we have to take this one is common, and the left hand side is here z1 z2. Is it clear? So now here after writing this result, now here what we need, according to our question, we need real part of z1 z2, isn't it? So real part of z1 z2, so that means this one is the real part of z1 z2, isn't it? And this one is what? The imaginary part of z1 z2. So we need the real part of z1 z2. So that's what you have to write here, real part of z1 z2. Real part of z1 z2 means this one is the real part, isn't it? And this one is what? The imaginary part. So real part we have to write. So this one is x1 x2 minus this one we have to write here y1 y2. Is it clear? So now if you see again z1, for the first complex number z1, what we write here x1 plus I y1, and the second complex number is z2 we write here, and this one we write x2 plus I y2. So in this case for the z1, x1 is what? The real part of z1, and y1 is what? The imaginary part of z1. Similarly here x2 is the real part of z2, and y2 is what? The imaginary part of z2. So as a whole, if you see here for z1 z2, this whole part is the real part of z1 and z2. So that's why we write here real part of z1 z2 equal to this. So now here individually x1 is what? x1 is the real part of z1. So that's why we have to write here real part of z1. Is it clear? Into x2 is what? x2 is the real part of z2. So that's why we have to write here real part of z2. Is it clear? Minus, now here y1. y1 means what here? y1 means the imaginary part of z1. So that's why we have to write here imaginary part of z1. And y2 is what here? The imaginary part of z2. So that means we have to write this one is imaginary part of z2. Is it clear? So I think this one is our proof, and we need to prove this result. So here we get the proof. Is it clear? After completing the question number 2, if you see the third question here, the third question is given a complex number here given, which one is not given in a standard form, is not it? So what you have to do, we have to convert this result, this question here, whatever the question given, this question we have to convert this one into a standard form of a plus ib. So the question is this one. If you see here 1 by 1 minus 4i divided by minus 2 divided by 1 plus i into this result. So first of all, what you have to do, we have to convert this one into a standard form. So for standard form, first of all, what you have to do, we have to multiply, or we have to take LCM in between these two. Is it clear? So if we take LCM here, first of all, so now here the denominator we get here 1 minus 4i. So 1 minus 4i into 1 plus i. This one we write here. So if we take LCM, 1 minus 4i cancel. So 1 into 1 plus y. So that means here remain 1 plus of i. Is it clear? Next one is minus. So 1 plus I cancel with 1 plus I. Then what will remain? 2 into 1 minus 4i. So 2 into 1 minus 4i we have to write. Is it clear? and the second part remains same, and which one we have to write here? 3 minus 4i divided by 5 plus of I. Is it clear? So this one we write. So after writing this one, now if we multiply or if we calculate this result, now if you see here, so 1 into 1 plus I, that means we have to write here 1 plus I. Then next minus 4i, we have to multiply this whole result, isn't it? So that's what you have to write here, minus 4i. And this one you have to write minus 4i square. That means this one you have to write 4i square. Is it clear? So this one you have to multiply. So now in this way, if you check out the numerator part, then this one we have to write 1 plus I minus 2 minus minus plus, so 2 4s are 8. That means this one you have to write 8i. And the other part remains same here. Which one we have to write? 3 minus 4i divided by 5 plus of I. Is it clear? So now here, if we calculate this result, now finally if we calculate this result, then what we get here? We get here I square. I square means what? Minus 1. So minus minus plus, so that means plus 4. 4 plus 1, here we get this one is 5. Is it clear? Then similarly here plus I minus 4i, that means what we get here? Minus 3i. So that means we write here minus thrice I. I think all of you understood this one. Similarly, if you see the numerator part, 1 minus 2, that means what we get here? Minus of 1. So this one you have to write minus of 1. I plus 8i, that means we have to write here plus 9i. Is it clear? And the second part is remain same here. And which one we have to write here? 3 minus 4i divided by 5 plus of I. So after calculating this one, now we get this result. Minus 1 plus 9i, 5 minus 3i. Is it clear? Okay. Now after calculating this one, the next part is, if you see here, if you see what you have to do, we have to multiply again these two denominators. So if we multiply these two denominators here, let's see what we get. If we multiply these two denominator, 5 minus 3i into 5 plus I. So 5 into 5 plus I, that means 5 5s are 25 and 5i. So that means if we directly multiply here, 25 plus we get 5i. Is it clear? Next one is minus 3 into 5 plus I, minus 3i into 5, that means minus 15i. So that's why we have to write this one is minus 15i. And next one is minus plus minus I into I square, that means minus 3i square if we multiply these two results. So similarly, if numerator, if we multiply minus 1 into 3, that means we get here minus of 3. And similarly here, if you see here, minus 1 into minus 4i, that means plus 4i. So we have to write this one is plus 4i. And the next part is here 9i into 3, that means 27i. So that means plus of 27i, isn't it? And now here 9 4s are 36, plus minus minus here, so minus 36i square, I into I. You see here, this one is I into I, so that means I square. So after multiplying, we get this type of result. So now here, if we calculate this one, if you see here, I square minus 1 minus minus plus, so that's why 3 plus 25 here, we get this one is 28, and then this one is how much? 15 minus here 5, that means minus of 10i. I think all of you understood this one. 25 plus 3, 28 here we get, and then minus 15 plus 5 minus 10i. Similarly, if you see the numerator part here, I square means what? Minus 1 minus minus plus, so 36 minus 3, that means how much we get here? 33. And this one is how much we get here? This one is 31i. So now if you see here, from the denominator, or if you want, then you keep this one like in this way, or if you want, then you have to take 2 common from the denominator part. So that means if you take 2 common, that means what will remain here? 33 plus 31i. And if you take 2 common, then this one remain here, 14 minus 5i. Is it clear? Okay, now after that what you have to do? Now again, if you see the denominator part here, 14 minus 5i is there. So we have to eliminate this I from here. So what you have to do? We have to multiply it by their conjugate, is not it? So that's why here the numerator part remains same. So that's why 33 plus 31i, and this one is 2, and here we write 14 minus 5i. And now we have to multiply it by their conjugate of this denominator. So the conjugate of this 14 minus 5i is what? We have to write this one is 14 plus 5i. And to balance this result here also we have to write 14 plus 5i. Is it clear? So we have to multiply these two. And now after that, after calculating, if we multiply this one, it is of the form a square plus b square, is not it? After multiplying this one, then we get the final result here. So the calculation is yours here. So calculation, so big calculation you have to do by yourself. Is it clear? So if we calculate, finally the answer here we get 307 by 442 plus up. If we calculate this result here, 307 by what we get here, 442. If you calculate the whole result, plus 599. This one you have to get 599 by 442 into I. Is it clear? So this one is the final result. After calculating this, we get 307 by 442 and 599 by 442 into I. So this one is a standard form of a plus ib or not? So this result we have to find out like in this way. Is it clear? So the calculation part is here. You have to do this one by yourself. Is it clear? So today we complete 3 questions from the miscellaneous exercise. So in this way you have to continue this exercise. So lots of questions are there. Actually we have to do some important questions from here, and the other questions you have to do by yourself. Is it clear? Okay, thank you.